Time travel, we see it everywhere, in movies and books, right? But have you ever stopped to wonder what the actual laws of physics have to say about it? Well, you might be surprised to hear that our best theories don't say no. In fact, they kind of seem to say maybe, which creates this huge universe-breaking problem. A problem that the one and only Stephen Hawking came up with a truly brilliant solution for. And this is just classic Hawking. Instead of some dry academic paper title, he gives us this wonderfully playful idea, a chronology protection agency. He's basically picturing a cosmic police force, making sure no one goes back to mess with history. And that one simple, clever phrase perfectly sets the stage for one of the coolest ideas in all of physics. So where does this whole time travel headache even come from? Well, you can thank Albert Einstein. It all starts with his theory of general relativity. And it turns out, when you really push the math of that theory, you don't just find things like black holes and warped space. You find what look like honest-to-goodness blueprints for time machines. Now, physicists have a fancy term for what a time machine creates. They call it a closed time-like curve, or CTC. But don't let the name intimidate you. Just think of space-time as a giant highway. Normally, you can only drive forward. A CTC, though, that's like a bizarre off-ramp that loops all the way back to a part of the highway you've already passed. It's a time loop. The most famous example is probably a wormhole. You've seen these in sci-fi, for sure. It's a tunnel connecting two different places in space. But here's the wild part. If you could build one, you could also make it a tunnel connecting two different points in time. You could literally step through a door and walk out yesterday. I really want to let that sink in for a second. Our best, most tested, most fundamental theory of gravity, the one that explains everything from falling apples to the orbits of galaxies, that theory contains the mathematical possibility of traveling into the past. It's not a mistake in the math, it's a feature. And it's not just wormholes either. Oh no, physicists have cooked up all sorts of other weird possibilities. You've got things like Tipler cylinders, which are these infinitely long, super dense spinning cylinders that would drag space-time around with them. There's even a solution for an entire rotating universe. All of these crazy cosmic objects could, theoretically, act as time machines. Which, of course, leads to the big question, right? If our best theory says this stuff is possible, and the universe has been around for almost 14 billion years, where is everybody? Why aren't we tripping over tourists from the 25th century trying to get a selfie? That lack of future tourists actually points to a much, much bigger problem than just the engineering challenges. The real issue is that time travel, as fun as it sounds, is a complete and total nightmare for logic. It threatens to break the most fundamental rule of the universe. And that rule is causality. You know, cause and effect. It's the simple idea that the cause has to come before the effect. You flip the switch, then the light turns on. Time travel just throws a grenade into that whole idea. It lets the effect happen before the cause, and that just shatters reality as we know it. And here it is, the classic example that makes your brain hurt, the grandfather paradox. Imagine you build a time machine, go back, and you accidentally stop your grandfather from ever meeting your grandmother. Well, if they never meet, your parent is never born, which means you are never born. So, who went back in time in the first place? See? It's a complete brain-melting contradiction. So physics is stuck, right? On one side, you have Einstein's theory saying, hey, maybe you can. And on the other side, you have basic logic saying, absolutely not. This is the moment Stephen Hawking steps back in with a truly elegant way to solve this whole mess. He called it the chronology protection conjecture. It's a big phrase, but the idea behind it is actually pretty simple. He hypothesized that the laws of physics themselves basically conspire to make sure time travel is impossible, at least for anything big enough for us to use anyway. In other words, the universe has its own safety net. That whole chronology protection agency idea, it isn't some group of guys in cosmic uniforms. It's just a fundamental part of the laws of nature. The universe has a built-in system to stop paradoxes before they can even start. Okay, so a built-in safety mechanism sounds nice, but for a physicist, that's just not good enough. You have to ask how. What is the actual physical process that could be powerful enough to stop a fully formed time machine from working? Well, the answer, it turns out, is amazing. It's not gravity that does the job. It's gravity's much weirder, much more chaotic little sibling, quantum mechanics. The bizarre rules that govern the world of the super, super small are what protect the timeline of the super, super big. What you're looking at here is a great visual for how this works. It all comes down to something called vacuum fluctuations.
See, even totally empty space isn't really empty. It's fizzing with these tiny, virtual particles that pop into and out of existence constantly. Most of the time, they're harmless. But near a time machine, they become a weapon.
Let's walk through this, because it's so cool. So you turn on your wormhole time machine. At the exact instant it's ready to work, one of these little virtual particles pops into existence and flies into the entrance. It travels back in time, comes out the other side, and here's the genius part. It emerges in the past right next to where it's about to enter. So it can go through the loop again, and again, and again, and again.
What you get is a runaway feedback loop. The particle and all its future versions start piling up, all trying to exist in the same tiny spot at the same time. The energy in that one spot just builds and builds and builds until, according to the math, it shoots straight up to infinity. And what happens when you pour an infinite amount of energy into one point in space-time? Kaboom! The universe unleashes a blast of energy so powerful it rips the wormhole apart. It gets destroyed at the precise instant it becomes a usable time machine, meaning it can never actually be used. The universe protects itself. Now that is just a beautiful self-correcting mechanism. It's so elegant. But, and this is really important to remember, there's a reason it's called the chronology protection conjecture. It's a fantastic idea, but it isn't a proven law of physics. Not yet, anyway. So, what's the holdup? Why can't physicists just declare victory and say time travel is impossible? Well, the problem is that violent self-destruct moment happens in a realm of physics that, frankly, we just don't fully understand yet. Right now, our calculations rely on a sort of mathematical duct tape called semi-classical gravity. It's an approximation that lets us use general relativity and quantum mechanics together, but it's not the full picture. It breaks down in these extreme situations. To get a real final answer, we need a true theory of quantum gravity. And finding that theory is, no joke, the holy grail of modern physics. It's the whole reason things like string theory exist, to try and build that one unified theory. Until someone cracks that puzzle, we can't be 100% sure that Hawkins' conjecture is the final word on the matter. Which leaves us with a pretty fun thought to end on. Is time travel really and truly forbidden by the laws of physics, or could it be that the Chronology Protection Agency is just so incredibly good at its job that it destroys the time machine and any evidence it ever existed so perfectly that we could never even know? Makes you wonder, doesn't it?